Yes,
right. On the
percent.
side. Okay,
I mean, so the 20 volunteers, we can say here for sure that this one is like 35. And this one is
okay.
probably 75 because out of 20, I mean, we can be more specific, I guess, if you want. You could say that the red survey, so 25% means that 5 out of 20, 5 out of 20 went blue, and 15 out of 20 went red. Then on the blue survey, and the reason we can do that is because, I'm sorry, you said 35, so that's 7 out of 20. 7 out of 20, 13 out of 20. Because we know to get to with 20, it's by fives when you're doing percentages. The blue survey, 75 went blue, so that's 15 out of 20 went blue. And then 5 out of 20 went red. And then the control, you can do the same thing, or you can say 12 out of 20 went blue and 8 out of 20 went red. So you could, for example, add up all the reds. And you can say 13, 5, 18, 26 out of 26 people were red.
Okay.
Uh,
People prefer red. Okay.
and then you can do the same thing for the blues. You could go, okay, it's 7, 15, and 12. That's 34. 34 blue.
Okay, and then basically just plug that into a sentence for describing what you see.
Yeah, and actually, like you said here, I mean, 29 actually summarizes that information for us, which is it's exactly what we just did. It's summarized a little better in this table. So let me show you that, because that's maybe how you can see how.
Oh, right, it's got the table on it. Okay.
Yeah, and then it's got those same numbers,
question.
26, 34. We had all these numbers in there, so we got it. Okay. So if you to answer 27, you would maybe just look at 29 and do this, or go down the progressions we just went down for that.
Okay. Oh, did you receive the questions on 29, or did you just get that image?
I've got all of them here. I just
okay.
Yeah. So you're doing chi-squared distributions. Is that right?
Yeah.
Okay.
It seems to be the.
All right. So yeah. So letter A here. State the appropriate null and alternative hypothesis. So from class, you probably talked about dependent versus independent.
Right.
Okay. Or no association.
Yeah. I've mentioned. Yeah.
So the word, like, this is where I'm not sure exactly what you guys are doing in your classroom, and
it's basically like the HO and then like plugging it in, and then the HA and plugging it in.
Right. But what I'm referring to is like these have like more of wording.
Okay.
No association. Sometimes you see the word like independent, or and then the alternative would be that they have an association.
Oh, I see.
And that they are dependent. And I don't know what you guys are using because I don't have your book in front of me, but you can quickly scan the chapter or maybe the back of the book there to get this.
Would you be able to put that in an AP course? Like the alternative and the null?
It's typically in words, but you have to add in the two categories. There's no association between the color of candy and the survey type.
Okay.
So you have to add that in your color, candy, survey type.
Let's see here. It's that one. 1920.
Okay, so
so it's the or what it says here is the distribution of candy choice is the same for subjects like these who receive the red survey, the blue survey, and the control survey.
Yes.
And the distribution of candy choice is not the same.
Yes, so that's referring. So the chi-square can also be used for a distribution. So in this case, it's saying the distribution is the same, basically, like you think it's uniformly distributed, and then the alternative is that it's not that distribution.
Right. Okay.
Okay, and it really is this specific here. I grabbed this, from this is what I thought I was referring to with the categorical variables here, but you guys are using a distribution. So
Okay.
there's two ways to use a chi-squared. One is for whether it has a certain distribution. The other is whether there's an association between two or more variables, or two categories, we'll say, with subcategories, basically. So it sounds like you're down this route over here.
Okay.
All right. So
Okay.
that's A. Uh, okay. So B here says to show the calculation for the expected count in the red cell. And so let me go grab that table one more time here to do that. So you actually need the expected value in for every cell.
Okay.
All right. So the one they want is this one where I've got that marked in there. So to do that, you take the row total times the column total, and you divide it by what I call the total. So numerically, it would be 26 times 20 over 60. So I'm grabbing that number for the row total, column total, and then total.
Okay. So that's like the actual formula for it.
Yeah. Now
Total.
some books round to the whole number. You're not supposed to do that. You're supposed to actually like just leave it unrounded, but you have to do it. Then you have to do it for all of these.
Okay.
So you have to get what's called the expected values for all of them. And so it's kind of rough. Like you know, the blue one here, after we get this one, the blue one, you got to do the same thing, but you're now using this 20 instead of the other 20. But they're the same, but you're moving, you're using the row total and the column total, and you're in over the total.
Okay. Huh. And that's to get the expected count.
Yes. So we need that. You do need that. Like what you need here is another table, red, blue, control, red, blue, with the expected counts for each of them.
And can you
And
use the calculator to find the
oh,
expected
absolutely.
count for all of them?
Oh,
So I remember like the teacher showing us something about that for like a certain
I
one.
want to say yes, but I don't know right offhand because I haven't done this in a while. So
Yeah.
I'll look real quick
It's
here.
in the matrix one for the x minus one.
Yes.
And that's kind of like the editing it, and then you can like put in all this information, and then it could give you the total count of all of them, I believe, but I'm not too sure. I need to.
It does sound right. I mean, you would generally use I'm looking this up right now. So that enter goodness of fit. No. I'm not sure that the calculator will do the expected, but if you do create two matrices for the observed and then the expected, you can do the calculation that you're
Okay.
looking for. Um,
Okay. Cool. Cool.
for now, because I haven't done this in a while, and I don't want to take up your time doing that. We should just get these calculated here
Okay, you got
real
it.
quick. I'm gonna do it another way.
Let me see. So, and oh shoot, what's that number?
That number that I crossed out,
Yeah, it's all
13.
good. I got it.
Do you have some numbers here for us?
Shoot, yeah, a few of them I see here. So it was 13. Sorry, I'm relearning calculator. Finally, I actually have one at home too, which is nice.
Yeah, we'll save some time here.
What's the row column? So that'd be 26. And then divided by, oh, yeah. So for that one, it'd be, oh, whoops,
So you're
hold on.
using
So
the row total of 26,
26, and then,
column total of 20 divided by 60.
oh, okay, I accidentally, okay, so that's that one. I'm sorry, I accidentally put in the 13 instead of,
It's okay.
okay, so then, yeah. Same. And then, okay, so it's the same for all of them.
Well,
Except-
it's not supposed to be the same. It's because this number here,
Right,
the column total, like and you get, and that's maybe it's designed that way on this AP, but no, in general, they're not the same.
they're not the same. It's usually kind of like all out of
Yes,
kind of
yes.
crazy.
So
Okay,
you got to remember this formula up here. I don't know how you do that, but you just stare at it and it makes sense. That's part B. That's part B. Part C is the big one. That's where using your calculator can help. I think, let me show you how to do that. So the test statistic is, I'm trying to get back to where, yeah, calculate the value of the test statistic. So the test statistic is a formula here. Let me snip this in. It's the summation. It's the summation. That's what the sigma means, of the observed minus the expected squared over the expected.
okay,
Okay, so like just to go back to this, it'd be like taking this 13 that's observed, 13 minus the 8.67 squared divided by 8.67.
okay.
So in terms of how you do this in a calculator, I'm not sure. I'll try it with you. I mean, I never use a calculator for this, so this is a little bit of a guess,
Oh
but
no, don't worry, you're all good.
you make a matrix for this first one. That's 2 by 3, 2 rows, 3 columns, 2 by 3. Okay. And then you like, let's just say that's A and B. And I'll try this as well on my side. It would be A minus B squared over B. Don't know if it's going to like that because I don't know how. So let me try it.
Okay.
And I'll, get back to you. Do you remember to do two matrices? It's second matrix edit, I believe.
Yeah, yeah. No, I already
You know
plugged
that? Okay,
all
you're
those stuff in.
okay. So let me do this here.
Matrix. All right, got that edited in. Oh. When you go to edit, you would edit it in, and then once you have it, do you have to do B as well and put
Yes,
those in?
you got to put the expected ones in. There
Right.
might be a way to calculate it. I'm not sure.
Yeah, no, it's good.
Yeah, so it doesn't like that. I guess I got to do that. Maybe that. And then I got to take the sum of that.
Yeah.
Add the whole thing up.
Okay. I think I got it.
I've got the answer because I used some software I use also for that six. So you should get. So like here's what the calculator gives you if you do it. You're going to get a matrix with those elements, 6 elements in there, and you really need the sum of all the elements.
Okay.
Now I'm struggling here a little bit to actually have the calculator give me the sum, but it does appear to work. Like, I'm just looking at the numbers. It does appear to give you the 6.65, which is the one that you want.
Yeah, no, that's exactly what I got too.
Okay, fantastic. So maybe ask the teacher or ask someone in class how to get these expected ones from the calculator. I'm not,
I remember there was a way to do it. It's just like, you know, as soon as you leave and you leave it for a day, it's like you forget the numbers of
yeah,
everything else.
yeah, and we can look into it as well if we need to, but that takes care of that.
Okay, perfect.
I believe that's everything for that one. So,
Okay. And then do we have enough time for another one,
well,
or
let's take a look here. So what do we got? What are we up to?
we got 31, which is a reference to the last one as well.
Why can't I find it? There it is.
The last candy.
All right. Verify that the conditions for interference are met. I don't know what that means. You gotta have to, that's something from your book.
The conditions are reference. Okay, let me take a look.
It stands like it's like the standard, like, what are the assumptions needed for a chi-square distribution? And whenever
Okay.
something says verify, it's already true. You mean,
Okay.
but
So yeah, it's basically like kind of like the random, like is it like, you know, checking if it's random
I,
or
I
the
I believe this one has a specific thing where each cell has to be greater than 5 is one of the things that you're looking for.
right, that's the large counts as she calls it.
Okay, and that's, then there's a couple, there's like one or two, like you said, independence, all that. There's a list of that. That's not
Yeah.
real important in practice.
Okay.
So this is more important though, is to find the p-value. So
Okay.
the chi-square distribution is always, this is like a multiple choice, it's always positive. It's always greater than or equal to 0. Okay, it's typically always one-tailed as well. So that number we just found, the 6.65, we want to find the area out here in the right tail. You do need degrees of freedom. So the degrees of freedom is the columns -1 times the rows -1. So if you go back to your table here, you've got 2 rows and 3 columns. So you got 3 minus 1 times 2 minus 1. Degrees of freedom is 2.
Oh, okay.
Okay.
Yeah, perfect. That showed up on the calculator too, I noticed.
You can do a chi-square something on the calculator.
Yeah, it's the chi-squared test.
You don't need the test though for you want to go to second distribution because you already know the distribution.
Okay.
Let me find that real quick.
The chi PDF or the chi CDF.
So because you want the area, and it even says that here, you want the CDF.
Okay, the CDF.
Yes. Now, what I'm not sure of is the syntax. So I don't know what it probably wants, like a lower and then an upper.
Right.
And so your lower is 6.65, your upper is 10 to the 99. The last one is usually the degrees of freedom.
Okay. So like I usually just put like a really big number for the upper.
Yeah, 10 to the 99 is a good choice. I do have the p-value if you want to.
Yeah, it's a 0.036.
Yep, perfect.
Perfect.
Okay, so
And you
now
can
we can
round up with that as well, right? With the p-value usually.
whatever it says there. Yeah. So this, because it doesn't say in this problem, so I'm not sure. I
Okay.
like p-values to 4 decimal places. That's kind of the standard that I see.
Okay.
Interpret the p-value. I'm not sure why they're asking you to interpret. It's just a number, but in this case, your p-value is, how does it compare to? They want you to draw the confusion. Okay.
So they're like comparing the red candy with the blue candy people.
Well, you're gonna reject H0, but that's from, no, I'm sorry, you're not. Sometimes they want you to actually say, like, this is the probability of a type 1 error.
Right.
Is the p-value. I really don't know what else it could be asking for here.
Okay. Here, I can take a look at the answer real quick. And
Sure.
so if it was question 31,
Part C.
Assuming the distribution of candy choice is the same for subjects like these who receive the red survey, the blue survey, and the control survey, There is a 0.036 probability of observing differences in the distribution as large or larger than the ones in this study by chance alone.
Okay, and that's a type 1 error. Basically, it's saying like type 1 error is when you reject the null hypothesis and it's actually true.
Right.
You're saying like there's still some possibility that we're not quite right.
Okay. So yeah, the p-value is the probability.
Yes.
Okay.
Part D
And
is well, kind of where I thought you guys were going, which is you compare the p-value to your alpha. If your p-value is less than your alpha, you reject
okay, is that
H0.
always the case?
Always.
Always the case. So if p-value, I always got confused with that whenever I saw it in class. I was just like, how do you determine if you reject or
It's always this. If it's less than alpha.
alpha level? Okay. Reject. Okay. Good to know.
So
And then
this one you would fail to reject, just to be clear, because it is
right.
not.
It's over. Okay. Oh, shoot, I had a question. So like if there isn't an alpha level like told in the question, is there
There
a
has to be.
specific level?
There has to be.
It
There
isn't
has to
like a
be.
situation where you
No.
have to pick one. Okay, good.
No.
Okay, and then yeah, okay, that does make sense. All right.
All right, we're pretty much here at the end of our lesson for 37. It's another chi-squared distribution.
Yeah. I wanted to ask, are you still doing the lesson with my sister today?
I am. I mean,
Okay.
you're welcome to work that
Yeah,
out.
I talked with
her.
my mom, and she was willing to switch out with Atalanta
Sure.
or my sister, and then that we could do a little bit more work if that's cool with you.
Yeah, whatever you want. You guys are the
Awesome.
customers. You tell me what you want, but
Okay.
we can stop here for now
Perfect.
and
Yeah, we can
pick up
come back
there
to it in
later on.
second one.
All
I'll
right.
probably have different ones. I probably should just get the rest of the homework out of the way.